Alright, hell yeah. So this video is all about cosine of inverse tangent of x. I came across this and I'm just like, I don't know what to do. You know what I mean? But now I do. This is so cool. So one, anytime that you have inverse sine of, like, hey, this is not an angle. This is a ratio. You know what I mean? So I would actually write it out. Inverse cosine of a ratio. So this x right here is a ratio, even though that you could have sine of x, and hell yeah, that's an angle. So that's kind of the first thing. Now, what is the ratio? So that's the first thing that we do is we draw a triangle. Sometimes I do like a 30-degree triangle. And what we're going to say is, let's go over here. So hell yeah. So here's our little triangle. And if this is the ratio of tangent, tangent says opposite over adjacent. So this is going to, and if that is equal to x, then hey, this has to be x and this has to be 1 because x divided by 1 is x. Okay, sweet. So now we can kind of chill it out. And well, the one thing that we can do is we can for sure know that inverse sine, inverse cosine, inverse tangent, they give you angles. So this whole thing right here is an angle. And so is this. So this is the angle. So if I have cosine of an angle, well, now I know what to do. You know what I mean? Cosine of the angle, well, let's what is cosine of the angle? Those are the two that you should know. Sine of an angle and cosine of an angle, they're going to be percentages. Usually the sine is in the vertical direction if your angle is this way. Sun is shining on the sinin. And then cosine is going to be adjacent. But these are percentages of the whole hypotenuse, you know, which is really useful when doing vector stuff. Anyway, so cosine, this is going to, so cosine of an angle is going to give me a ratio. And that ratio, if this is my triangle, is going to be adjacent over hypotenuse. Now let's say we didn't know what the hypotenuse is, but this is like numero uno. Rule number 1, anytime you're doing anything with trigonometry, never forget about Pythagorean's theorem. The more you're using Pythagorean's theorem, the more that you know what I mean? You definitely know that you know more than other people if you're breaking it out. But sometimes, so this one, it's going to be really easy to use Pythagorean's theorem. This is going to be x squared plus 1 squared, square root that. Hell yeah, that is going to be the hypotenuse. Okay, so now what do we say this cosine of our angle is going to be? It's going to be a ratio between the adjacent and the hypotenuse. So we have 1 divided by x squared plus 1. Hell yeah. Alright, so then I was just like, oh sweet, so we can burn out anything. We could do sine of inverse tangent. So again, inverse tangent's a ratio. The ratio is going to be x divided by 1. Sweet, we're going to have this. If we have the sine component, sine of that angle is going to be a ratio. That's going to be x divided by, so we have that, x divided by the hypotenuse. Alright, sweet. So now let's challenge ourselves. And what I wanted to do, alright, hell yeah, look at this one. I wanted to do inverse tangent of x, but we're going to take the tangent of inverse tangent. So let's write it again. We want to take the tangent of inverse tangent of x. This is something that you commonly do. If this is the ratio, but you're taking the inverse tangent of it, this is going to give you the angle. But if we take the tangent of that angle, hey, that's going to give us the ratio again. So basically, tangent of inverse tangent of x should be x. So how do we kind of prove that? Well, let's go back to what inverse tangent is. Well, no, hold on. We're going to say, well, I don't know. It's kind of just an identity. So we're going to say, hey, this is the ratio right here. Here's our triangle. We have x divided by 1. That's going to give us that ratio. And if we take the inverse tangent of it, it's going to give us that angle. And then here's the triangle. And then if we take the tangent of that angle, sweet, that's going to be this side divided by that side. That's going to be the ratio, x divided by 1. And hell yeah, so it just kind of proves itself. I don't know, you know what I mean? Leave a like if this video was crazy. And thanks for joining me. Oh, hell yeah, we got one more in us. Because what we wanted to do inverse cosine of x and then take the tangent of that. So hell yeah, so we're going to have tangent inverse cosine x, and we're going to use, this is really going to really hone it in. So let's come up here to our triangle. If we have, this is going to be cosine, and then this is the ratio again, remember? So if here's our angle, where's the ratio for cosine? It's going to be adjacent over hypotenuse, and that's going to equal x. So hey, our adjacent has to be x, and our hypotenuse has to be 1. Okay, now let's rip out Pythagorean's theorem. Now you should be able to do this just knowing that this is the bigger number. You should be able to get to, hey, it's going to be 1 squared minus this other thing. You know what I mean? 1 squared minus x squared square root that is this side. Just like if you have both these sides, you're going to take this squared plus this squared square root it is that hypotenuse. But just know that if you're trying to find an aside, this hypotenuse is always the bigger number. So when we're going to square that, we got to subtract this squared. Sweet. Okay, sweet. So now let's so that what the hell are we even doing? So the ratio of this. Oh, we already got that. So the ratio is equal to x. So we have x divided by 1. So we're set there. And now here's our triangle. You know what I mean? Here's kind of the shape, and here's kind of the values that we have on it. We're going to take the tangent of that. Sweet. So the tangent of that is going to be opposite over adjacent. So we have square root of 1 squared minus x squared divided by x. Or basically square root of 1 minus x squared divided by x. And hell yeah. And that now, anytime that I come across, you know, two of these together, I'm not just going to lose my friggin' mind. Sweet.